Okay, so I found these 50 NumPy functions very useful for data science. And as I go through these, go ahead and say these aloud in your space that you're working in, or in your just in your head, say them aloud. But we'll start with the array and the line space here. So the array is used to create one-dimensional arrays or multi-dimensional arrays. And the line space is used to create an array with an evenly spaced float or floating point numbers over a specified interval. Okay, so now let's do the next two. Here we have a range with one R, and we have random.uniform. So a range returns an evenly spaced integer values over a given interval with some step size. So pick your step size and it'll return integer values over that step size. And uniform samples will generate a random sample from a uniform distribution between a lower and a higher limit values. So you'll notice several parameters here: a lower, a higher, and the size. Alright, next up here we have two more random methods. We have the random.randint and the random.random. If you're just joining us, or if you've skipped forwards, go ahead and repeat these in your head so you get familiar with speaking them. Random.randint generates n number of integer samples within a range, or the random.random generates n random floating point samples. So what do you need? Do you need integer samples or do you need floating samples? That's a big difference between those two. And this uses a uniform distribution for the uniform samples. Next we have this logspace. Different types of spaces. Logspace generate evenly spaced numbers on a log scale. So you notice generate. So we need some numbers to work with. In this case, if we want to use a log scale, we'll use logspace. I say logspace, you say logspace. I say zeros, you say zeros. And there's another one. I say ones, you say exactly. So the ones function helps to create an array of 1. If you notice here, a bunch of ones. And then the zeros creates an array of zeros. A bunch of zeros. Next up we have k random value. And that is using the dot full. So if someone asks you, what function should I use to create an n-dimensional array of a random value? You can say the full function. Fills the inside of the array. Fill it up. Next up we have identity. Which creates an identity matrix. So if you need a matrix, if you need a specific type of matrix, you can use identity. And then we have our minimum and maximum, very common array operations. for identifying the highest value and the lowest value. And then we have unique. So if you want to return the elements that do not have a duplicate, so there's only one of them in your data set, very useful. I say unique, you say, all right. Next one up is mean and median. And I think there's a mode here too, but I haven't seen it yet. So we'll just notate these. And there's the mean, which is could be arithmetic or geometric. I'm not sure which one this is using, but we have the median too, kind of a statistical probability concepts here. Digitize returns the indices of the bins to which each value in the input array belongs. So if you're into the concepts of binning, you'll need a bin and a write parameter. And you will use digitize. I say digitize, you say exactly. Now we have a reshape, and this is reshaping some random int data. Now this actually declares it to be one of the most useful. It actually returns an array containing the same data, but with a new shape. So you'll see that this matrix is shaped differently than this matrix, and then this is a third matrix, linear matrix looks like. Expand dimensions, expand dims. So these will probably go along with the reshape. But if you need to expand the dimensions in your array. Good for creating sample test data prior to machine learning. Squeeze. We are squeezing. What are we squeezing here? Reducing the dimensions of an array by removing single dimensional entries. So get rid of the single dimensional entries. I say squeeze, you say squeeze. Great. Next one, count non-zero. So how many zeros are there? We don't care for this function, but how many non-zeros are there? In this case, there's 3. Argwhere. Find and return all the indices of non-zero elements. So 0 elements are treated differently than non-zero elements. If you want to return all the indices of those non-zero elements, use the argwhere. Now there's an argmax and an argmin. So in line with the argwhere, you're going to have an argmax and an argmin. Argument minimum, argument maximum, argument where. And again, these are all returning indices of the max. And a lot of times the max is the highest probability. Argwhere returns the indices. Argmax returns the indices. Argmin returns the indices. All right, moving on to sort. If you need to order your items, there's 3 kinds of sorting you can use in your parameter. Quick, merge, heap, and stable. That's a good interview question. Name 4 kinds of sorting in NumPy. Quick, merge, heap, and stable. All right, we will do the absolute value here. if you want to return only positive values. And we'll do 2 more here, and then we'll move on to part 2 in a separate video. So we have round. If you need to round up or round down. And the number of decimals to keep. Do you want to keep 3, 6, 9, however many? And the final one here in part 1 is clip. It is used to keep the values of an array within a range. So you have this range. I only want certain values within the range. I'll use the clip, and you can see this author used the clip several times. Okay, so this is essentially 50. I think we're going to end up having more than 50, but I'll make a note of that. I'm going to guess 54. NumPy, numerical Python functions for data science. All right, stay tuned for part 2.